Hello there, and welcome to our notes for probability of events involving not and or. If you are in the standalone version of this course, this is going to be notes 4.7, and if you are in the co-requisite version of this course, this is going to be notes 6.2. Problem 1. Answer the following questions. When a single fair dice is rolled, what is the probability of? So our sample space, this is the list of outcomes, is 1, 2, 3, 4, 5, 6. What is the probability of rolling a 7? Well, 7 is not in our sample space, so the probability is 0. What is the probability of rolling a 3? Well, there's only one way to roll a 3. The sample space is 6, so that's 1/6. Again, that could be represented as a decimal number. What about not rolling a 3? Probability of not a 3. Well, if there is one way out of 6 to get a 3, then that means that there are 5 ways out of 6 to not get a 3. So our probability is 5/6. What is the probability of getting a 3 or a 4? Well, there's one way to get a 3. There's one way to get a 4. So there's 2 ways to get a 3 or a 4. Our sample space is 6. 2, 6 simplifies to 1/3. Okay, so let's talk about the probability of not. Recall that the complement of a set, written as A prime, is the set of elements that are in the universal set and not in A. So a complement of A, written as A prime, is the set of elements that are in the universal set, but not in A. So here's the visual. Here's our universal set. There's a bunch of stuff in the universal set. We defined a space called A. We'll call that set A. So there's stuff in A, which is still in the universal set, but there's some stuff that is not in A. That is a prime or a complement. So the idea is this. If you know the probability that A happens, we can define the probability that it does not happen by subtracting the probability from 1. So, problem number 2. If the probability that South Plains College wins a basketball game is 7 out of 10, what is the probability that it will lose the game? Now, some of this can be answered just by thinking about it, but let's get into the practice of utilizing this idea. So, the probability that they will lose a game is equivalent to 1 minus the probability that they win the game. So, in terms of assigning some numbers to this, 7 out of 10, that's 7/10. So we have 1 minus 7/10, which is equal to 10 tenths minus 7 tenths, which is 3 tenths, or 0.3, which is equal to 30%. There is the probability that they are going to lose the game. When a single card is drawn from a standard deck of cards, what is the probability that it is not an ace? So the probability that it is not an ace is equal to 1 minus the probability that it is an ace. Now, to answer this question, we might need to come back and think about what is the probability that that card is an ace. Well, there are 52 cards in a standard deck of cards. 4 of those 52 cards are going to be aces. Now, we could simplify this. Let's go ahead and simplify that. That's going to be 1 out of 13. So the probability, actually, let's not simplify this. Let's leave it as 4 out of 52 for the time being. We'll simplify at the end. So the probability that it is not an ace is equal to 1 minus 4 out of 52, which if we rewrite 1 as a fraction with a denominator of 52, that's 52 out of 52 minus 4 out of 52 is going to be 48 out of 52. Which will simplify to 12 out of 13. There are 48 ways to not get an ace. Sorry, I said 42. 48 ways to not get an ace. 48 out of 52 simplifies to 12 over 13.